Lesson 3.3 homework. Decide whether or not the given sequence converges to a limit. If it does not, find each case at least one convergence subsequence. Okay, the first problem, we have negative 1 to the n times 5 over 3n. But this one is the summation of the previous one. So let's take a look at that. Okay, so here we have x to the n from x sub n equals to the summation of I equals 0. A lot of times it starts with 1. This one starts with 0. To the n from negative 1 to the n times 5 over 3 to the n, where n starts with 0. 1, 2, 3, and so on. So we want to see if this converges. If it does not converge, then we want to apply the Bolzano-Weierstrass theorem to see if we can get a subsequence. So if this doesn't converge, then the subsequence will. Well, the last problem, it did not converge, but the subsequence did. Well, let's see if this one converges. So we start with n equals 0. That would make us x sub 0 equals to the summation of I from 0 to 0 from negative 1 to the n times 5 over 3 n. And so that's negative 1 to the 0 times 5 over 3 to the 0, and that just leaves us with 5. Okay, because anything to the 0 power is 1, right? So that changes that negative 1 to a positive 1, and so that's 1 times 5 over 1, and that just gives us 5. Okay, the next one, and now we're not going to keep doing this, but I want to show you what's going on with this sequence. So now we have I equals from 0 to 1, from negative 1 to the n, 5 over 3 to the n. So now we're doing this one here, negative 1 to the 0, 5 over 3 to the 0 plus, and then we're going to do 1, negative 1 to the 1 times 5 over 3 to the 1. So we already know this is 5, and so this will be plus a negative 1 times 5 over 3, so that'll be a minus. So this is 5 minus 5 over 3, so we need a common denominator, so we use 3 over 3, and we get 15 over 3 minus 5 over 3, and we get 10 over 3. So this is n equals 0 and n equals 1. Okay, so now we look at n equals 2. So that'd be x sub 2, and now I equals 0 to 2 for negative 1 to the n, 5 over 3 to the n. And so this is negative 1 to the 0, 5 over 3 to the 0, plus negative 1 to the 1 over 5 over 3 to the first, plus negative 1 to the squared times 5 over 3 squared. Well, we already know that negative 1 to the 0, that's 5. And we already know that these two together is going to be 10 over 3. So we can just put this 10 over 3. Now all we have is plus negative 1 squared, that's 1 times 5 over 9. So we need a common denominator, so we multiply 3 over 3 here. So that's 30 over 9 plus 5 over 9, and that's 35 over 9. So you can keep going on like that forever until you get a convergence. But there's a lot easier way to do this instead of going through all these calculations. So let's get the calculator. All right, and so again, like before, you want to make sure your mode is you go down to function, make sure you're in sequence, and hit enter. Then you're going to go to second and list. Now before we went to math and then sum and then sequence, but because we're dealing with a summation, we need a cumulative. So instead we're going to go to ops and then 6 for cumulative sum. So this is mode, function, sequence. Okay, so that's just to set up the sequence, and we're already in that, so we don't have to mess with that. And then we go back and second and list, and this time instead of going to math, we're going to ops, and then we're going to cumulative sum 6. Okay, so we hit 6. Okay, and then we go back to second and list again and ops. So we go back to second and list again and then ops. Okay, and then we're going to go to 5. And then that'll be, then we go to 5 for sequence. And then we put in our equation and everything else. Okay, so back here. That's not what we want. Second and list, math, 6. Okay, let's start over. Second and list, ops, and 6. There we go, that's better. And second and list, and ops, and 5. Okay, so we're going to go ahead and put in our equation, which is negative. We put in open parentheses, -1, close it to the n power, and then open parentheses 5 divided by 3 exponent to the n power. That's this. Close the parentheses. Our variable is n. Start. We're starting at 0. Starting at 0. So we'll put 0 in here, and we're going to go to, let's try 10. Step is 1, because we're checking out the original sequence. We go to paste. Okay, and this is what it should look like. Cumulative sum, sequence, -1 to the n, times 5 over 3 to the n, where n is our variable, from 0 to 10, and our step is 1. So let's hit enter. All right, and so if we look at it, if we go into math and then fraction, and you can just hit enter because it's just 1. Here we've got what we started with, 5, that's 5, 10 over 3, 10 over 3, 3, 5 over 9, that's what we had here. So it's going in that sequence. And if we keep going, okay, it looks like, well, it's hard to tell. But if we keep going here, we get 3799, 3750, and so far. So if we went further, if we went back, second and list, ops, 6 again, and then second and list, ops, 5 for sequence. Okay, this time we had the same equation, but this time let's go to 20. And leave it step 1 again. And so you see we have 3.3, 3.88, 3.70, 3.76, 3.744, 3.751, 3.749. So it's converging to 3.75 and 3.7499. So the points, if you looked at it on a graph, they're doing this. They're getting closer and closer and closer and closer to 3.75. Okay. And so if we keep going 3.57500, 3.74999, 3.75000, so we can conclude that we can conclude here that it converges to 3.75, and that's our answer. And that concludes this video.